Hey everyone, hope you are having a great time here today at BountyCon. My name is Richard, and I'll be sharing a little bit about hacking Android apps with Frida. Just to give a bit of high-level overview of this talk, we will first go through the basics of what Frida is, just to make sure that everyone can follow along, and then I'll be sharing a methodology that I like to use. I will then be doing a quick demo using Frida, including how this methodology can be applied. And then I'll finish it off with a couple of real-world examples. At the end of the talk, there will be a couple of minutes of Q&A, and so if you have any questions, please feel free to ask me at the end of the talk. I'll try my best to answer them. I also wanted to add that this talk is mainly for bug bounty hunters who are trying to get into mobile testing. So if you've been doing web app testing for a while now and looking into getting more into mobile, this talk could be helpful for you. And for those mobile pros out there, hopefully there are also something for you to take away out of this talk. So anyway, please sit back and enjoy this talk. So firstly, please allow me to quickly introduce myself. Well, I am currently a pen tester at Trustway Spider Labs, and I live in Melbourne, Australia, with my wife and little boy. In terms of bug bounties, I only started getting into it sometime early last year, but totally got hooked after getting my first payout. So probably similar to a lot of you guys, I try to juggle work during the day and then spend time during the night hacking away on Google, HackerOne, and Backcrowd. I personally like to hunt on mobile apps because I think the competition isn't as fierce compared to web apps. But that's just my opinion. Anyway, that's a bit about myself. Let's talk more now about Frida. So, what is Frida? So those of you who have never heard of Frida before, it is a fantastic tool created by Oli Andre. Sorry if I'm pronouncing it wrong. But what's cool about this tool is that it is a dynamic instrumentation toolkit, which lets you inject snippets of JavaScript into native apps. You can use Frida for a lot of other OSs, but in this talk, we'll be focusing only on the Android side of things. It's scriptable, portable, and very lucky for us, free to use. So here's a little bit more information about Frida according to the official documentations. Frida's core is written in C and injects Google's V8 engine into the target processes, where your JavaScript gets executed, and I stress here, with full access to memory, hooking functions, and even calling native functions inside the process. So in other words, Frida is like a debugger. It helps you modify and analyze application at runtime, which means that you as the tester can be in control of how the application behaves, which makes it really powerful when it comes to testing mobile applications. Apart from that, it also allows you to inspect and modify memory content. So now you might be asking, cool, Richard, you've just given us a bunch of definition of what Frida is. So what now? How can this be applied to bug bounties? Well, when testing mobile apps, normally there is a barrier to entry, as it requires bypassing security controls that the developer has set up. This includes SSL pinning and root detection, which is very common. There are also other types of controls out there, such as what we call anti-tampering signatures, which essentially prevents you from tampering API requests. Well, Frida can help you with that as well, depending on how the signature is generated. It can also be used to identify hidden secrets. There has been multiple instances that Frida has helped me to find sensitive credentials in memory, which would otherwise be really hard in heavily obfuscated source code. Other types of use cases include automating attacks such as brute forcing and fuzzing. Okay, now let's go through setting up the test environment. So there are generally two ways you can use Frida. One way is using it on a jailbroken phone, which is personally my preferred option. Essentially, you upload the Frida server binary onto the jailbroken phone and then run it using ADB. It's pretty straightforward, and I'll show you in a second how this is done. The other way you could use Frida is by injecting what we call a Frida gadget into the target APK. This requires repackaging the app, but the good thing about this method is that you can run it on a non-jailbroken device. So it's up to you how you want to do it, but I like to use the first option because it's just quicker. So to run Frida using the first method is pretty simple, and it requires you to connect your jailbroken Android device to the workstation. You first install Frida tool on your workstation using pip, and then you download the Frida server binary from GitHub. Extract it, and then upload the Frida server binary to the mobile device itself. Change its permission, and then finally run it as a background process. Okay, now we have our test environment set up. Next, I'll share a methodology that I found useful when testing Android apps with Frida. So when you first get a mobile app to test, after doing your initial reconnaissance and understanding how the app behaves, you want to define the problem and goal. So for example, what are we trying to achieve? Are we trying to bypass certain restrictions perhaps, or try to access certain resources that we shouldn't be able to? Once that is defined and we know that Frida can be used to help us achieve our goal, we then try to analyze the application. We do that by first decompiling the app. An APK tool and JetX is normally a very helpful tool that can help us with this. We then look at the source code and try to identify what we are supposed to hook. This step normally takes time, but once we know what to hook, we then use Frida to hook that method and change the app's behavior to how we want it to behave. Let's go through a simple example and apply this methodology. So this is a simple application called CrackMe from OWASP. You can download it to have a play if you haven't played with it before. But when you first open the app for the first time on the rooted device, you will see that you get detected and forced to exit. So applying the first step of the methodology, the problem is that we have a root detection in place, and our goal is to bypass it. So next, we extract the APK offline and try to decompile it using JetX. We then try to analyze and determine which method we need to hook. Because the code is not obfuscated, we can easily search for common strings. In this case, searching for the string root leads us to the method A in the main activity class. Okay, so now we know which method is the culprit. Let's try to hook that method. On the JavaScript code on the right, you can see that we are hooking the A method in the main activity class. Now what's cool about Frida is that you can read arguments being passed into the method. In this case, we're using console.log to print the original argument being passed. In addition, we can also change this argument, which is what you're seeing in the next line. So in essence, the Frida script is used to hook a specific method, read the current argument being passed, in this case, root detected, as you can see over here, and change what is being displayed. In this case, we are changing the string to show the word hacksaw. And as expected, this is what we get. Now let's change the app behavior to bypass root detection. In the Frida script, let's just do nothing when the method is hooked. And as a result, this control is now bypassed. We successfully used Frida to solve our issue. Now that we have a bit of feel for what Frida can do for us, and also a simple methodology that we can use to follow, I would like to share some real-world bug bounty examples. So this story is about hacking an e-wallet mobile app. Just a bit of a side story though. When I first saw this app, I wanted to work on it because I noticed that it required a Malaysian or a Singapore number to authenticate. I'm not living in either countries at the moment, but do have friends or family members living there that could help me buy a mobile number if I needed one. So what this means is that the competition with other researchers is significantly reduced because without the mobile number, a lot of researchers will not be able to properly test it. And that would put me at an advantage to avoid those duplicates. Anyway, what was interesting about this app is that it had a lot of interesting functions. For example, it had instant messaging, linking personal bank accounts to the app, transferring money between users, topping up mobile credits, buying vouchers, game credits, and so on. So after my initial reconnaissance, I started to proxy traffic using Burp. What I noticed, unfortunately, is that there was no way to tamper with the API requests. I'll show you what I mean. For example, the app had a function to send gifts to friends. These gifts are what the Chinese call red packets. If the response returns a 200 OK and states that the surplus number is 1, as you see over here, that means that the red packet has not been claimed by the recipient. It's just sitting there until the recipient opens the virtual packet and the money gets transferred. So the most obvious thing to try is to change the red ID value to see if we can view the status of other red packets. Well, sadly, that didn't work out. I tried to increment this value and receive a 401 unauthorized. What's interesting though in this response is that we get a signature check fail. So it means that by us tampering the red ID value, the signature is no longer correct. So going back to our methodology, our first step is to identify the problem and the goal. What is the problem? We don't have the right signature. And what is the goal? The goal in this instance is trying to find a way to recalculate the signature. Can Frida help? Maybe. Let's give that a shot. So I first extract the APK from the device and then use JetX to deep compile it so I can view the source code. Quick tip here though, if you ever had issues with JetX running out of memory, because by default I believe only 4 gigs of RAM is allocated for the application, you can try to increase it by using the command over here. Next, I needed to find out how the signature was being generated. So the easiest way for me at that time was to search for strings. In my case, I searched for the API URL and then slowly trace it back to this specific code. The application was taking the red ID value and token value, concatenating it together, and then sending it to the MD5 util encrypt method to perform some sort of encryption. So this is the encrypt method that we are interested in hooking and could potentially help us solve this issue. So now I know roughly how and where the signature is being generated. So I wrote this simple Frida script. Let's go through it together. We want to hook the MD5 util encrypt method, which is what we saw before. And each time that the method is called, we want to run through a range of red ID values. In this case, value from 0 to 400, together with the user's token, and then pass it back into the same function again, which is encrypt. And then finally, print out the corresponding signature onto the screen. So now we start Frida and attach the script to the running process. Each time that I perform an action on the app that uses the encrypt method, it is going to run that script. As a result, this generated all the signature that I required. Now remembering that these values are what is required to make a successful request, let's try putting it into burp intruder and see how it goes. And it worked. I was able to find red packets or gifts that has not been opened by the recipient. I did a little happy dance for a while, but then thought, well, that's all good knowing which other red packets belonging to other users are available. But can I maybe use the same method and maybe, just maybe, try to steal the money instead? Turns out this was possible as well. There was another endpoint called drawRed, as you can see over here. This request is the request used to open a corresponding red packet that has not been opened before. As we know which packets are available to steal, I could use the same concept of generating a signature for a corresponding red ID value and then use it to perform this action to steal other users' red packet money. Nice. It seems that many sensitive endpoints in the app were vulnerable to this. I took a deep dive in this application and tried to discover as many endpoints as I could that I could exploit. The end result was that I could abuse quite a few endpoints to perform sensitive action such as deleting another user's bank account, joining different private chat groups, viewing other user transaction details, and also personal information as well. The weakness stems from the fact that the developer probably assumed that just because user can't tamper with the request, there was no way to perform unauthorized actions. So just like other types of IDOs, the fix was to ensure that access controls are also applied server-side appropriately. Okay, cool. So we've seen how Frida can help us manipulate a mobile app to our advantage. In the next example, I'll share how Frida can also be used to help us automate other types of attacks. This story is about how I was able to use Frida to help decrypt encrypted files stored in an application. So just a bit of background. The application had a vault function which allowed users to store their files locally with encryption. So if I took a sensitive file, maybe a picture of my driver's license, and stored it in the vault, the file would be encrypted and stored locally on the SD card. Now we all know that storing sensitive information on the SD card could potentially be risky because that means that any other application on the same device with read storage permission would be able to access and steal the file. But then you would say, hey, that's encrypted, right? So there's really no risk to it. Well, hold that thought. Another interesting thing is that to unlock the vault, the user requires to enter the correct PIN. But the thing is that there was no limit to the number of attempts to unlock the vault. This screenshot shows where the encrypted files are stored, as you can see over here. It is stored in the hidden folder of the SD card. So we now understand a bit about the application. Let's try to apply our methodology once again. So the problem is that even though malicious apps can steal the files because it is stored on the SD card, there is no way to view its content because it is encrypted. So the goal is to see if we could find a way to easily decrypt these files. We also know that encryption should be performed client-side. So if we need to figure out how the files are being encrypted or decrypted, maybe Frida can help us. Well, let's check it out. So once again, we extract the APK offline. You can normally do this by downloading the APK through a third-party website, or even just downloading it directly from the mobile device itself. And then use JetX to decompile the APK file. You can see in this instance, the source code is obfuscated. Next, we'll try to determine or maybe guess which method is actually performing the encryption and decryption. I tried searching for the word decrypt, encrypt, and a couple of other common keywords. And after a bit of trial and error and testing, ultimately the unlock method over here that you can see is the method we are interested in. What this method is doing is that it is taking a string, in this case the pin, doing some checks, and if the check passes, we return something. Otherwise, it returns nothing. I then wrote a little JavaScript to be used by Frida to manipulate the application. Let's go through it together. I first use the vault class and then hook the unlock method, and then log the original argument being passed into the method. In this case, this is the original pin number that I manually place into the application itself. This is just a sanity check. And then Frida will loop through all the values from 1000 to 9999 and then feed each value into the hook method. The return value of each iteration is then logged and displayed onto the screen. Hopefully this makes sense. Okay, so now we are ready to perform the attack. So just to recap the attack scenario, if the files in the vault were stolen, for example by a malicious application, and the attacker now has a copy of the encrypted files, the attacker could load it onto his phone and simply decrypt it by brute forcing the pin. In this case, it should be pretty easy for him because he can automate the attack using Frida and the script we talked about in the previous slide. So for our proof of concept, we first create an encrypted file on one device, copy it to a different attacking device, start the same application, and run the command Frida -u for USB -l for script, and followed by the package name. We then try to enter the pin after the application starts up in the vault and the brute force attack starts. I'll show a quick demo over here. On the left, we are first logging into the device as root and then starting the Frida server. And then over here is the script that we prepared called frida.js. And on the right, we are starting the attack by injecting the frida.js script into the process. In the background, you can't see it, but I'm actually now loading the application and putting 000 as the pin to the vault, which is not the correct pin. And then the attack begins. And when the correct pin number is found, in this case 1010, it returns a slightly different response, indicating that is the correct pin number to the vault. So those are a few examples on how Frida can help you perform automated types of attacks on Android apps. I hope these practical examples have been useful and will give you some ideas on how to use Frida to attack Android apps. So here are some key takeaways. Firstly, Frida is awesome. And I think that it's a really powerful tool that can help you find a lot of bugs that are often missed by other researchers. You don't have to do it, but I personally think that having a systematic approach when finding bugs can take you a long way. So when possible, use Frida to understand how the application works and then tweak it so it behaves to how you want it to. There are a lot of other tools out there which are powered by Frida. So please check them out and use them to your advantage. And finally, practice, practice, practice. If you're new to this, it can be tricky at the start, but the more you do it, the quicker and more efficient you become. And that's it. Thank you for your time and attention. My contact details are at the bottom of this slide if you want to reach out, but otherwise, that's all from me. Thank you, everyone, and have a great day.